Thank you all for coming to my theater session. My name is Katy Shimizu, and I am a software engineer too on the app services team. Specifically, I work on Azure Functions, and the specific part of Azure Functions that I've been spending my time on these last couple of months is our new extension for advanced scenarios, Durable Functions. So let's get started. We've got 20 minutes and a lot of material to go through. This is a 300-level talk, so I'm going to be going into a bit more detail than you got if you, for example, watched the keynote on Monday. The serverless keynote with Nir, not the Satya keynote. I don't know if he talked about this at all. Anyway, so quick plan. How many of you are familiar with the term serverless? OK, I can skip my first two slides. How many of you are familiar with Azure Functions? I can skip my next two slides. Great, we can dive right into Durable. So I was going to do a serverless refresher, but not anymore. So we'll dive right into some of the challenges of serverless as it stands today. When you are architecting things with Azure Functions. And then we're going to talk about some of the potential solutions to those challenges with durable functions. So let's get started. OK. Don't need this. Don't need this. Don't need this. Don't need this. I don't need this. All right. So what is still hard with Azure Functions? Very, very quick rundown for anyone who didn't raise their hand that I didn't see. Azure Functions is an event-driven serverless platform. You upload your code, it fires based on some sort of event that comes in, and then you can bind your calculations and so on to some sort of output. Some things, however, are still difficult to do in durable functions, or are difficult to do in Azure Functions. For example, if I want to take the output of one function and use it as the input into another function, I have to coordinate that somehow. If I want to have one function take some sort of event and then parallelize some sort of work, I can still do that in Azure Functions. It involves a lot of queues. But then how am I going to, say, pull all of those back in? How am I going to tell when all of those tasks have completed and aggregate all the results that I got and then keep going? What if I want to aggregate a bunch of events into one function? What if I want to listen on multiple events? What if I want to do different things based on what kind of event I get in? What if I want to do some extended status monitoring on some endpoint? I want to see, hey, maybe this machine, I want to check its temperature, right? And if it goes over a certain threshold, I want to take a particular action. If it doesn't, or if it goes under a certain threshold, I want to take a different action. How do I do that on a time basis and have flexible logic that works with that? What about if I have an API that's running for a very long time? What if my Azure function takes, say, 5 minutes to complete? We hope they don't. They're supposed to be fairly fast running, but you guys are putting some serious load on them sometimes. So if my Azure function takes a while, my client is waiting for 5 minutes, and that's pretty unacceptable in those situations. How am I going to communicate back to my client, hey, I'm working, and here's something that you can check in the meantime so that they're just not left hanging? And lastly, what if I need to have some human interaction in there? What if I'm doing something like phone authentication and verification? What if I'm doing some sort of two-factor auth? And I want to get some sort of human interaction in there, but I also don't want to wait forever, because sometimes we don't reply to all our text messages, especially if they're automated. And I want to have some sort of timeout. How would I do that in Azure Functions? And the answer to some of these is, I don't know. But I will talk about two of the patterns and how you would approach them in Azure Functions, and then how you could approach them in Durable. So let's look at the first, simplest case, function chaining. Function output becomes input, and then it all comes back, and I do something with it. Well, in regular Azure Functions, some of you have probably set up something that looks like this, where I have a function that puts its output onto a queue, and that queue triggers another function, and so on and so forth for as long as you want to go. And you can do that. I've done that. But the problem I found as my workflow got longer and more complex was that I had a lot of resources to manage, for one, and two, I became the only person who knew how they all fit together, and that is not a position that you want to be in. I made a Visio diagram. I tried to make it better. It was out of date in 5 minutes. Do not get into this situation. So enter Durable. Durable is an advanced extension, like I said, for Azure Functions. You would install it like any other extension, like your Twilio or your SendGrid extensions. And it allows you to coordinate long-running stateful workflows directly in your code. So how many of you have experience with logic apps? OK, fair number. All right, so you've used the logic apps workflow. It's the drag and drop UI process. This is sort of like logic apps, but instead of a graphical user interface, you are defining things in code. And that allows you to use some of our familiar code constructs from C# that we all know and love, like exception handling or task.whenAll, in order to coordinate lots of different tasks. So slightly different flavors, work for slightly different situations, but we think that this is a good one if you like using code to coordinate all this stuff. So in durable functions, we introduce the concept of an orchestrator. And this is a fourth function of these three that will orchestrate what happens between those. It's responsible for calling and receiving the output of what we call activity functions. They're what you're familiar with as normal functions. When an activity function returns, its return value becomes part of the local state of the orchestrator function. So you are able to work with it as you would any other variable in that block of code. And what does it look like in code? Well, it's pretty simple. So this is a very simple durable function orchestrator. We're just going to call one activity, F1. We'll get its result back into variable x. We pass that in as the input to function 2. We get it back as variable y, and then we pass that in as input to function 3, take that result, and pass that out of our orchestrator. And I can do that all in 3 lines of code. I'll go into how durable does this in a little bit. The other thing is that if I want to have exceptions in my code, say something goes wrong in a particular function, I can do that right in code. We're all familiar with the syntax, and now I can do it in a distributed way. When an unhandled exception is thrown in an activity function, that exception gets marshaled back to the orchestrator, and the orchestrator can handle it. If the orchestrator doesn't handle it, the orchestrator will fail, but we hope you're handling things gracefully in your orchestrators. All right. So, time for the first demo. I'm going to show you what this looks like. Let's go over to VS Code. Unfortunately, the conference demo goblins have gotten to my Visual Studio. It's not quite working right, so I'm going to show you the VS Code version. So this is very similar to what... Seriously? All right, 1 second here. There we go. All right. And it is still flipping out on me with something I tried to do just before I started. OK, there we go. So let's start up the functions host. And I might have made the font size a little bit too big, so let's turn that down. There we go. Can everybody still read that OK? Cool. And this thing is doing a thing to me, so let's change this name. There we go. Stop that. All right. Cool. OK, that's going to start up. It's going to load our extensions. And in the meantime, let's look at what's going on in the code here. So very similar to what you saw, just instead of generically named F1 and F2 functions, we have a function called SayHello. And all SayHello does is it will take whatever it's given and put it into a string that says, hello, thing that I was given, with an exclamation point. We're going to do that 3 times. We're going to put those outputs into a list of strings, and then we're going to return that list. So let's go over here. I am in Postman. I am dragging Postman over to the window where everybody can actually see me being in Postman. OK. So I will call my orchestrator. And you'll see that immediately I get back this piece of JSON that has 3 endpoints for me that I can go and follow. The first one is my status query endpoint. And this will tell me what is going on in my orchestrator as it's running. Now, that orchestrator completed really fast, so we already have our results back. But you can see it gives us a status. It gives us our input, our output, some timestamps. And you can also customize the status if you want to do some, hey, I'm in the middle of the orchestration process, have something a little bit more specific than I'm running. If I had been a little bit faster, you would have seen the runtime status was running and the output was null because it hadn't completed yet. All right, so over here we can see that it is replaying, and we'll talk about the replay behavior a little bit. Let's look at another example. And this one is it's a more complex pattern. We're going to take an arbitrary directory path, file path, and then back up everything that's in that directory to a blob storage account in the cloud. And what I want to point out here is that, so first I'm calling an activity function, e2getFileList, that will get me all the files in that directory. And then I'm using callActivityAsync to copy each file to a blob, but instead of awaiting on each one as I call it, I add all those tasks to a list, and then I use task.whenAll to wait on them. So in, I don't know, about 7 lines of code, I'm able to do that fan-out, fan-in scenario that would take bunches of queues and lots of monitoring to do in regular Azure Functions. So let's run this one. And I am going to give it, do a little sneak peek here. I'm going to give it the JavaScript samples folder because we support both C#, F#, those are in GA. And JavaScript support is currently only available for the V2 runtime, but it is in preview as of build. So that's my feature. I'm proud of it. All right, let's check out what's going on. We can see it's still running. If we go over to our console here, we can see it's called a bunch of copy file to blobs, and it's waiting on all those to come back. Give it a bit to run. Not yet. If I go over into Azure Storage Explorer, unfortunately, I don't think I can increase the font size on this, but we can see, oh, that was a previous run. But I can see that there's a sample file, a sample folder created, and my JavaScript samples should start showing up in there as this function runs and restores them up there in parallel, or it could crash on me. All right. Clearly, I did not burn enough incense, but you get the idea. OK. And, oh, I almost forgot. I also have those samples in JavaScript. So we want the durable functions experience to be pretty seamless, whether you work in C#, F#, or Node.js, or just vanilla JavaScript. So we have tried to make it feel pretty intuitive and native. In this case, instead of the await keyword, we're using the yield keyword. You can find out more about this on the repo, or just talk to me after, because I like this feature. It's mine. And the backup site content looks very similar. OK. So how does this all work? Come on. There we go. All right. So how this all works is that we use a pattern called event sourcing to store state in a backing Azure storage account. This is how we make our functions durable, as it were. Whenever you get a request into an orchestrator, and the orchestrator code is up top there. It's as simple as I could make it for the sake of time and fitting everything on the slide. So you would not actually use an orchestrator to just call one function and then do whatever. But when you get a request into the orchestrator, it will run until it hits some request for async work. In C#, it's the await keyword. It will check its execution history to see, did I actually execute that yet? If it did, it will go ahead, but it didn't in this case. So it's going to say, hey, I need to schedule this work. It will call into the underlying extension framework to do that. And then it'll go to sleep, because it's just waiting for this stuff to happen. It has nothing else to do. That activity function will get woken up. It will run. It will create its output. And then the orchestrator function will get run again. And key point here to understanding this that took me a while, it starts over from the very beginning. And it goes to that line again. It will check its execution history. This time it has something. It will bring that into its local state. It doesn't have to schedule the activity function again. And it will keep running. So in a more complex workflow, you would go through this several times. Now, this means that you are only paying for the time that your activity functions are running and your orchestrator is running. So that's a compressed amount of time. It also means that I can do things like ask my orchestrator, hey, wake up in 2 days and check this thing again. And the durable task framework that underlies the durable functions extension will know how to do that, and it will just go and do that, but your functions are not running during that period of time in between. Okay. And so that is a quick overview. So takeaways here basically are that Azure Durable Functions make managing state and complex workflows in a word I forgot, but I meant to say in Azure Functions, easy and familiar. With our GA release, we have a bunch of improvements on the preview. If any of you have played around with that, we have improved performance. We now have support for large messages, so you can pass in messages that are bigger than 64 kilobytes. We have improved App Insights diagnostics. On top of the App Insights experience you get with Azure Functions, there are additional traces that we log so that you can tell what's going on with your orchestrators. How did my orchestrator work? When did it stop? When did it run? In a way that is a bit more transparent than looking just through the functions logs. We also integrate with logic apps, and the JavaScript is in preview. Okay. If you are here, please complete an evaluation form if you attended the session. That would be really nice. We love your input, and it helps us know as speakers how to do better. We have other serverless sessions going on at Build today. Catch Matt Henderson's Azure Functions and Microsoft Graph not too long after this. And then Building Mobile Apps with Xamarin at the serverless Azure Functions backend from Laurent. And this is me. So docs are at aka.ms durable functions. Pretty simple to remember. Those are our two main repos. And one of the things that I find really exciting about this project is that we're pretty open source. So with our GA release, we had contributions from, I would say, 6 or 7 community contributors that made the release a much bigger, much richer release than we would have had if it was just me and Chris Gillum and Ling To working on it up at Redmond. The Azure Functions Durable JS shim is in that second repo. That's what you need to run it in JavaScript. You can find me on Twitter and on GitHub. And so please, if there's any feedback that you have, please send it to us or file an issue in the GitHub. If you want to contribute and help, that's awesome. Talk to me and I can hook you up with the right materials. And I will take questions now. Okay, so question we had was, how do we control the polling frequency? That's a good question. I think that in our GA release, we have a setting that allows for that. It would probably go in the host.json. Let me double check with you and get back to you on that. It's a relatively new feature. Yes? Oh, yes. Okay, so the question was, is there a way to manage orchestrations? So the two other endpoints that I didn't name in the JSON stuff you get back are the ability to send events to your orchestration and also to terminate your orchestration. Also, if you have some sort of process that is calling your orchestrations, you can store the IDs of those orchestrations in memory or wherever you like, and then call in, see how they're doing, choose to terminate them, and so on. Is that kind of what you were asking? Right. Enumerating orchestrations that are out there. I don't think we currently have that capability, but it sounds like a good one. So yeah, file a GitHub issue if we don't already have one. Yes? Is there a limit to how long the orchestrator can run? That is a good question. So the question is there a limit to how long the orchestrator can run? One of the limitations on the orchestrator is that execution history, if you're running it indefinitely, can get very long. So if you know that your execution is going to be going for a long time, we have a thing called continue as new, and what that does is it starts up a new orchestration with the same ID, and you're able to pass state in from the old orchestration, and that means that you start with a fresh execution history. And this way you can get what we call eternal orchestrators that can run forever without ending up with, a list 3 miles long. Oh, and one other current limitation is that if you have timers, and you want to wake your function up after a certain amount of time, it's currently bounded by Azure Storage. So the delay is 7 days max. That's something we've had a lot of requests to expand on and make it possible to do longer stuff. People have come up with hacks to get around that. But for now, if you're doing it directly, it's 7 days. Is there a connector for durable functions and logic apps? So the way that you kick off an orchestration in durable functions is you have, they can be triggered on basically any type of Azure Functions trigger you have today. You create a starter function with the binding is durable orchestration client, and that client is used to start up your orchestrations. The one I was showing you was an HTTP trigger starter, but you can do it based on, if a message comes into a queue, if a blob gets uploaded to a blob storage. So your logic apps connector would just be to that starter function. And vice versa. I don't think we have a logic apps connector. I think with logic apps in general and functions, it's logic apps call the functions, not so much functions call the logic apps. I could be wrong. I need to find Jeff Holland and ask him, because he's our logic apps guy. OK, I am at 21:44, and I want to be respectful of the next talk's time. So thank you so much for coming and all your great questions. If you have specific, more in-depth ones, please visit me at the Azure Functions booth. I would love to talk to you about your scenarios. And thank you very much.